Uh, so I just uploaded a screencast of the same lab, and for some reason the audio wasn't working, so here I am doing it again. Let me actually just make sure first. My input device is working. You know what? I bet that was why I didn't get audio. Looks like it's working now, I think. So, this is the modification of the interest calculator in 5.6. It calculates and compound interest rate for every year between 1626 and 2020, which is 394 years total, on the original purchase price of New York, $24. Here the program begins execution. We set the format for our floating point numbers here, and we have two declarations, double amount and double principal, and initialized to $24. I'm sorry, 24. It's at 2 decimal points is the precision, so it'll print like 24. Sorry, 20, like 25.20 is the first amount, I think, $1.20 in interest for the first year at $24. And then here we have a for loop to calculate the varied compound interest from 5 to 10%. We set double rate equal to 0.05 or 5%. And when rate is less than or equal to 10%, increase rate. And then we have our display headers. Interest rate is showing the user in the console at the very top of our 2-column display of year and interest rate, that the interest rate is 5%. And then we have 2 columns, year with a column width of 25 and amount of deposit, which I did not set a column width for because 25 column width for a year pushes it out to the right far enough that it lines up just perfectly with everything that's printed below it. And we also have a for loop to calculate the amount on deposit each year between 1636 and 2020. We set int year to 1 for the first year, and then for every year that is less than or equal to 394, we add or increment the year. So I'll go from 1, do this loop, then go to 2, etc. And then we, in this for loop, we are storing in the amount variable principal $24 times the exponent of rate to year, the power of year. And I was looking online because I didn't necessarily understand why we were using this 1.0 here with rate. I assumed that rate itself to the power of year would be just fine to calculate the exponent. I think this is for the sake of the compiler. It's my understanding that the power function here does not calculate consistently across compilers and devices, and sometimes you get incorrect calculations. So this augmenting the function with this fixes that. Please correct me if I'm wrong on that, though. Here we print out to console the year and the amount plus compounded interest, with the column for year set to the width of 4 and amount set to 19. And once we've calculated all 394 years in this for loop, we transfer function back to int main, or execution, sorry, and return from the application. So I'm going to go ahead and run this now. It's really straightforward, just prints everything right off the bat. And you'll see here we have our first year $24 plus interest of $1.20, which is 5% of $24, and it just goes on from there for 394 years. And that is the entirety of this program. Thanks.